Hi everyone, I welcome you to the Piper Serica podcast where we explore bold ideas, investments, and founders shaping the future of the tomorrow. For those who are tuning in for the first time, Piper Serica is a multi-asset management firm investing into the public markets and the private markets. We have been investing into the sectors like advanced electronics, IoT, space tech, cybersecurity, and fintech. India's space tech story is entering into a different phase. Initially, it was institution led. For decades, the disciplined processes, the disciplined approach to procurement, the restrictions to enter into the TOT engagements have restricted a lot of innovations. But from the last decades onwards, the startups have been exploring into the multi dimensions, from satellite communications to the propulsion technologies to advanced materials. The startups are trying their best to get something out of the ecosystem. Building on this space tech is not something as easily scalable like the softwares where you set up the servers and explore the technologies and expand it to the people. It is about exploring the tooling, exploring the supply chain, exploring the manpower, training the talent, retaining the talent, and last above all, surviving through the global supply chain issues. Today, I'm having Manan with me, the founder of Thrustworks Dynetics, a company working into the intersection of all these problems or the opportunities you see. As often quoted by Mr. Musk, prototyping is hard, production is harder, and manufacturing and scaling things up is even 10 times harder. So today we are going to understand what they do at the Thrustworks Dynetics and how do they look into the space tech ecosystem and understand the work they do. Hi Manan,
Hi.
welcome to the podcast.
Thank you.
So Manan, first of all, can you explain me what the Thrustworks Dynetics does and how did you start it?
Okay, so Thrustworks Dynetics is a propulsion company. We design and develop liquid rocket engine systems and subsystems, and we commercialize them. We not only develop the hardware, we also develop the softwares to develop the hardware. So in that sense, we control the entire process from design, manufacturing, inspection, cold test to qualification in-house, enabling us to give our products and solutions at a very rapid time scale. So me and my co-founders, we met each other during 2019-20 time, just before COVID. And all three of us, we started working at Bharat Forge on a special projects group called as Project One, where we explored if we can build a liquid rocket engine using the existing capacities of Bharat Forge. During 2023's time, we formed our own company, got incubated at IIT Bombay, Sign. Shout out to Sign, by the way. And we opened a facility in Pune. So that has been our short journey.
So when you entered into the college and you started something, like, did you think the engineers who have spent years and they still, don't dare to start something of their own and into such kind of a technologies which require experience and specialization over the things, and you started freshly out of school? So what was the motivation inside? How did you started this, and what was the thought behind?
Yes. So for me, it was not a new thing. I have been building rocket engines ever since I was 13 years old. Solid rockets, worked with eminent ISRO scientists ever since while I was growing up. So it has always been a part of my life. Either it was before doing this work at Bharat Forge or after. It has always been a very incredible and very close part of my life. But I do understand that it's a daunting task to take up liquid rocket engine as a challenge, because it's an liquid engine are an engineering marvel. They are engineering marvels which just work at the edge of what is possible. So yes, it was a daunting challenge, but we never really thought about it like that. We always thought about it from a physics perspective and physics principle perspective. So when you analyze a problem using a physics perspective, you don't associate it with legacy. You associate it with what's possible. You look at the future, not at the past. And that's what drove us deeper into solving much more fundamental problems in liquid engines. And here we are.
So if others could understand this, can you easily explain what the liquid engine means?
Yes. So all propulsion in this world are of two types. We have air breathing propulsion, we have non-air breathing propulsion. Air breathing propulsions are your jet engine, diesel engine, petrol engine. All these engines are air breathing propulsion. Non-air breathing propulsions are propulsion systems like rockets, which do not breathe air from the atmosphere, but they carry their own air or oxidizer on board and they burn. Rockets are of two types generally: solid rockets and liquid rockets. So liquid rockets are ones which whose propellant is in liquid state, and solid rockets, I think everyone has used Diwali rockets. Those are solid rockets. So these are the two types of rockets.
So since you said when you were 13,
Uh,
you were still playing with this liquid rockets or the solid ones?
I wish I was playing with liquid rockets at that time, but again, fortunately or unfortunately, I was more into solid rockets for the starting period of my life. Explored a lot in sugar rockets, dextrose based rockets, then your gunpowder rockets, and so on and so forth, and build different classes of motors and build different systems using it.
Manan, you often speak about Anya engine. Can you tell me and the viewers what is it? How is it different from the other engine platforms? What you are doing differently here?
Anya engine is.
And
Huh?
what does Anya means? How did this
Okay,
come?
that's a good question. That's a good question. So, Anya in Sanskrit means inexhaustible. Okay, and Anya engine is a. I'll just speak a bit technical about it first.
Okay.
It's a 2-ton class. So it generates around 2000 kgs of thrust, uses ATF or kerosene and liquid oxygen as propellants, and weighs less than 20 kgs. So that's the engine configuration. Anya engine is a very different piece of I'll call it infrastructure than whatever that's available. I use the word infrastructure with a lot of thought in mind. Why? Anya engine is built as a platform engine. Okay, this is not a product to be used in as it is in the market, but it is built to be a platform engine which will then be customized to meet customer requirements. What really happens over here is we are trying to solve for few key problems. Aerospace lacks volumes. Because it lacks volumes, you are not able to split your development cost across a larger larger production. So your unit cost increases. Your And these aerospace systems generally become a lot of research and developmental projects, which cause a lot of delayed cost overruns and so on and so forth. Our thought process was, and the question that we ask more importantly is, how do we remove the R from R&D
Okay.
and make it a developmental work? Okay, so that's where we thought of an idea. Shout out to the operations and technical team for that. That Anya engine will be built as a platform engine and will be customized to meet customer requirements. So what this enables us to do is, this enables us to keep the supply chain very stable, very safe. It helps us. It helps us split our cost over a larger volumes of product. Brings in a resemblance of volume in this industry. We can go for a larger production cycles, and your testing infrastructure and inspection infrastructure remains the same. Ultimately, all of these things, what does it enable? This enables you to deploy your engine within months rather than years. This de-risks the customers so that they can use these systems faster, iterate, and and build their applications and solve for their problem statements.
So can I say you are making aerospace work like a software?
Yes, actually, that's a very good that's a very good analogy. I must say. So we have to think, okay, what infrastructure can we build which will be used for a mass and just by little modification. So yes, that's what we are trying to do. We are trying to build systems which are robust and can target large amount of problem statements.
Okay. So usually I've heard that propulsion itself is a physics heavy. So it requires the rigor of R&D and also the safety measures around it.
Yes.
So how do you ensure that these both are in balance with each other?
Yes, that is a difficult part. R&D, uh, that's a very, very good question. See, when you solve for this problem and you try to take out the R&D or the R part of the R&D, you have to do 10 times more R&D in the initial stage to remove the R of the R&D in the deployment stage. Okay, so what do? Is we do hundreds and thousands of tests. We generate data. Those data trains our machine learning algorithms. Those machine learning algorithms learn physics, whatever is happening, and then those algorithms then predict the solution, and based on those solutions then we design and develop the systems. Now while these system designs a solution for us, these algorithms design the solution for us, we have to also keep in mind your manufacturing issues, supply chain, tooling constraints, qualification constraints, testing constraints, inspection constraints. All of these things the softwares have to keep in mind, and then only they generate a design. That is the only way we can deploy engine in months rather than years. Because I'll give you an example. Sometimes for some of our toolings, just to get a tooling, we sometimes it requires 6 to 7 weeks. So if that's your lead time for just one tool in a very complicated system, it's very easy for you to escalate the timelines in years. So that's what we're trying to solve for.
So much constraints together. I'm often, since we have been speaking for a longer time, so you have always been speaking that propulsion is as human as it is mechanical. So what does it mean, and how do you bring these terminology together, like the importance of the human factor and the mechanical factor?
Humans are very important in this particular cycle, I must say. Uh, by the way, shout out to Vineet and Kalyani. Love you guys. These two are my co-founders, and working with them has actually taught me a lot about the symbiosis of human and tech. We are trying to build teams here. We are trying to build teams, autonomous teams who take decision and who execute on their own. Okay, when we build software, when we build hardware, when we build test facilities, the decision making needs to be with the people who actually understand the variables at that level and solve for that. And you, to do that, you require a very, very capable team. So because you want to localize decision making as much as you can while keeping the global vision aligned, you need very capable people who understand the variables and dynamics of decision making at that level. So that's where we really, all three of us co-founders, we really sat together and tried to understand that how can our teams lead instead of us being the face. Our teams need to then lead these verticals and move forward. So very capable people are required. You require people who have a lot of analytical skills. Their technical skills can be learned. Okay. But do they think? Are they curious? Are they passionate? These are the values that matter a lot. So we used to do a very, very interesting thing to hire people, is we used to give people an impossible problem to be solved in an improbable amount of time. And we used to ask them, this is the problem statement, you give me the time frame, how much time we will solve this in, and I will not take any follow-up. Now sometimes 99% of the people, they'll try to do it and they'll solve that, things will not solve, and they'll forget about it, they'll not respond back to us. But there will be few, they will have this problem stuck in their mind. Now weeks, months go by, and these guys are not able to take that problem out of their head. And just to solve that particular problem, they'll execute, and in weeks or months they'll solve that particular problem, and they'll come to us with a solution. Okay, I gave you like 1 week, but here I am after 4 months. This problem couldn't let me sleep, couldn't let me solve it. So here is the solution, and they try to solve it. Again, the correctness of the problem, the answer doesn't really matter. What matters is their ability to pursue it to the level of obsession. and these are the people that we have, fortunately.
So one of the interesting things that we have been able to figure out through our conversations, like uh, engineering skills, the skills to operate the tools, which builds up over the years, which is often ignored and not talked about, to get a precise equipment, to run a equipment precisely. So there is a lots of talent which requires, and it becomes a problem when you are solving for the supply chain. You have to develop the vendors, you have to train the vendors, and I'm sure, since you started with a very limited number of resources, it must have been the challenge for you as well. So how would you like to look into this and talk about your experience here?
Yes, through you, I would first like to uh, say to the audience, whoever is listening, is uh, if people around you are getting skilled up, please salute them. Salute welders, salute fitters, salute machining people, CNC operators, salute these guys, because these skill set are very, very important to build our country. Okay, I cannot express how important these skill sets are, these technical skill sets. And yes, you are your machine is as good as the operator. Okay, any machine, and you might be,
Okay.
that might be a fighter aircraft, or that might be a CNC machine, but machine is as good as the operator. So a lot of time and effort goes into developing your people, developing your supply chain, developing the operators who execute things at the machine, working with them, supporting them, making sure they understand what are the SOPs, why are the SOPs important, and they execute. So upskilling your vendor chain becomes a very critical responsibility for us. So that enables us to build good relationships with our supply chain and our vendors, and that in turn gives that relationship rewards us in multifold times. So I cannot mention how many times our vendors have gone sleepless for 2-3 nights because we needed to get our parts at correct time frame, and these people become very critical. The factory owner will sleep, your the managers will go away, but the operators will stay in the machine and they'll do the job for you. And working with them and building good relationships with them is very critical. And skill set, yes, it's a big gap in the country, but I think a lot more respect and a lot more uh, empathy and appreciation needs to go in that direction.
So, coming on to the point, since you talked about reducing the months of efforts into the weeks of the time. So, one part of this is the vendors that you talked about. And another part of this building the in-house manufacturing capabilities. It's figuring out the systems, it's training your manpower you have already talked about. So when you say that you will be able to reduce months of efforts into the weeks, so what does it take in terms of figuring out the processes?
So PDR in weeks and a tested engine in months is what our this code goes. And on the machining side of things, see, one has to really look at the cost of owning a machine or operating a machine with respect to the amount of articles that you are going to make from that machine. Vertical integration sounds very good, but it is also very, very resource intensive thing to do. Not just to get the machines, but to operate, maintain those machines as well. Sometimes you'll have machine companies will give you machine for very cheap, but they'll take a lot of money in maintenance and servicing of that machine. So there is a balance that comes in what can you do in-house and what actually is good to have with our vendors. So we have our supply chain companies, our partners, who actually build those capacities for us. So we provide an entire plan to them, we work with them, we sit with them, and there are a lot of such partners in and around us now, that we are able to push not just for prototype but even for production.
Okay. So one of the words that you mentioned, I often hear, and I, as an investor, we ask this question, building things in house, building things indigenized, building processes in house, building systems inside. But what I have been looking into the challenges, the fundamental components, something like as a small component which does the firing part of it, something as simple as igniter. It's not simple. I just word as a equipment in terms of output. So as a company, building those components in-house requires a lot of efforts, inputs, and the precision that you take. And you have figured out the software, hardware attempting for it. And there is another approach to source these things from outside, integrate with your systems, and make things even faster from the
Correct.
systems. So why did you make this conscious call of doing everything in-house?
Okay, so from everything here means from design to qualification of things, and we are doing it for our component component sub assemblies as well, and multiple technologies are being developed because of this. The conscious decision of doing that in-house is because of two very critical reasons. Anya engine is not the last product of the company. It's one of the first products which is going out. Developing this system in-house enables us to build uh, the second engine product, third engine product, fourth engine product, and it builds the competence and capacities in-house to build a long-term vision and long-term vision company. There you have to make a very conscious decision what is core to you and what is not core to you.
Okay.
Okay, certain things which are core to you, you keep it within you. Okay, and
Can you specify what is core to you, Manan?
yes, what will enable you to achieve your USP is the question that one has to ask.
Okay.
There are certain things which enables you to achieve your USP is what is core to you. Okay, certain things which does not enable you to achieve the USP, you can push it out.
Okay.
And you can have people come in and work on that and get tech to do it for you. Okay, so these are the two distinctions that one has to understand, because if you end up doing you end up solving all the problems. Smart engineers end up solving the wrong problems, end up solving problems that should not exist, and that's a big issue. So one has to choose what problems we need to solve and what problem you shouldn't solve, and get a solution from outside. And that's something that we really believe in. So we solve for problems which enables us to give our USP. That's the time frame in which we want to deploy the systems. And there are certain things which we do get from outside. That's a decision that you make. Okay, second aspect of the subcomponent development is because it enables you to commercialize the subsystems as well. So see, engine is a large product. It has a large system which is in development, but there are a lot of subsystems, technologies which get built through this, which have a market of their own, and we can actually start to deploy those systems and do pilots of those systems, of the technologies. So that's where these are the two reasons where we took a conscious decision of doing certain things in-house, and like vertical integrating certain things, and then taking assistance from vendors and partners for the other verticals.
I'll get into a question here, which I am sure at least every investor you must have talked to have spoken to you about. So, if you are building engine, why not the whole vehicle? And since on this topic we have often had the discussion on this, if we look into the aviation sector, like companies like GE, Rolls-Royce, a lot of companies, I wouldn't say a lot, but a very limited number of companies which have exclusively been working into the engine. So what does it requires a company to be called as an engine company? What does it take that it should remain focused on engines and applications around it, not the whole vehicle,
Yes,
as you say?
that's a very good question. See, what are we trying to build over here? We are trying to build an engine company,
Okay.
a company whose expertise lies in the engines, development of engines. What we have seen is any industry that actually grows starts with vertical integration, but as it matures, there is a horizontal specializations also come into picture.
Okay.
Okay, you take semiconductor, you take aircrafts, you take anything that you take, you have horizontal specialization comes into picture. And we see aerospace and especially this launch vehicle industry and space industry going through that inflection point, that there is vertical specialization is being developed and we are eyeing for a share of the pie. That's what sets us apart. And engine side things is we have a decadal vision of building newer generation of engine, high thrust, high impulse engine, microcombustors, and many different products. So these Anya becomes a stepping stone for us to develop these particular systems, develop these particular engines in the future, and we deploy these engines for customers to use in their applications. That becomes our core.
Interesting. So I have often heard that deep tech is long, propulsion is even longer. And so a lot of times you as a founder and your team has been putting a lot of efforts to building something up, right? How do you look into the return of these efforts or return of the engineering from your perspective?
So one thing that we really believe in is start commercialization as fast as you can.
Okay.
Developing technologies, you have developed technology, develop subsystems, run pilots. Okay. Execute at some place. Okay, take some things up and try to customize and deploy the solutions over there. What really happens over here is you always get tested, you always get validated at every step of the things, that your systems, the way you think, the way you are processing actually has some merit to it.
Okay.
So getting yourself being tested with the markets, with customers, talking to them, talking to everyone there is very, very critical. So return, when I say it on the financial side of things, is building technologies, at least small technologies of a larger system, commercializing them and get financial returns out of it, so that you know what you're doing is that the model that you have built is actually very viable, and then you scale up. That's something. Another side is why the team, me, Kalyani, Vineet, and our larger team, ops, tech, admin team, why are all of these people here, is because we collectively have a vision of building the most advanced propulsion systems that ever existed in the history of mankind. That's our aim, that's the vision that we are here for. And taking small steps towards achieving that vision, that's a big reward.
Okay.
So all of us, we could have sit anywhere that we want, we could have had a cozy jobs, we could have lived a normal peaceful life, but there's a bug somewhere. There's something that pokes around in our head of that
Might be a
curiosity.
feature.
वो कीड़ा रहता है ना. So there's something poking around in our head, that's a curious part. Okay, can we do that, and doing 1,000 tests and getting that correct data the 1,000 times and developing new technologies and proving, okay, this can be done, that is a very, very good positive feedback, and that's something that drives us.
I'll pick up the testing word of it. So, as many as aerospace founders have spoken to, they say aerospace is all about testing and iterating, right? A lot of times we have found out that the testing infrastructure, which is not available to them, right? When you do the hot fires, there's no, to record those calculations, there is no resources available. So a lot of times you have to figure things out, right? So what was the biggest challenge and the biggest achievement you have been able to figure out when it comes to figuring out the testing and qualification? Secondly, what is your feedback to the ecosystems who might be listening to us, that this kind of infrastructure should be facilitated or get availed so that more number of startups can utilize things up?
Okay, so on the testing side, yes, I agree, testing is critical and very, very important for an aerospace company. And testing systems is a very challenging part, because infrastructure, there are a lot of infrastructure requirements that are associated with it, especially rocket engines require safety areas and a lot of land and everything. So on that side, we have built India's first mobile rocket engine test facility.
Okay.
It's a mobile facility, 1 ton facility. You move anywhere that you want. Setup time is 18 minutes. 18 minutes, you set it up. You fire, you move, you are done, pack up, move out. So this facility enables us to do testing at designated testing zones. So you pick the entire facility up, move it there, strap it down, fire, wrap it up, come back. So this is a system that we have built, and many systems like this for our testings we have now in our in our backpack. Uh, the advice that I'm gonna push to the founders and the ecosystem as a whole is, please talk to each other, please rely upon each other. Okay, some people have certain strengths, other people have certain strengths. It's very critical that you engage with each other, exchange a lot of information with each other, because what this enables us to do is, everybody doesn't need to do everything. There are a lot of capable companies out there who, just if they talk together, they'll be able to de-risk themselves and build better products out. And Vineet, the ops team, and my co-founder, he says that every day we are solving a problem which can be a company of its own.
Okay.
So when such things comes out, you really want to rely upon companies around you and something, and take their assistance. And that's something we at Thrustworks truly believe. We will ask anyone and everyone. If we are not able to solve, we'll ask people, we'll try to solve it on their own, take advices, we'll talk to everyone and see what best can be worked upon for us. So being open to new learnings and new ideas is very critical over here.
From team, I thought of a question what I should have asked in the last of the podcast, but what's the next?
What's next?
Not for this podcast, but what's the next for you as a team, as an organization, as a company? What's the next phase looks like? The immediate phase in the vision that you're carrying forward.
Immediate things that we want to do is, liquid rocket engine has critical technologies. Your turbopumps being one of them. We want to make turbopumps commercially available for any aerospace company, so that that complete indigenous turbopump we develop and we deploy it for our customers, so that their journey of development gets shortened up. So that's something very critical for us. We are on our path to doing that. Additionally, on the larger vision picture side things, we want to push forward with new generations of propulsion systems. Once Anya systems and subsystems get commercialized, we want to push forward for some new generation of propulsion and power generation systems, just as microcombustors and high thrust high impulse engines. And we truly believe that now that there is talks of AI in space, and $100 trillion the thing is happening, whatever it may happen, may not happen, I'm not a fortune teller, but can we position ourselves to take advantage of the boom that is coming? We should, yes, we need to. So that's how we are trying to position ourselves and provide solutions which actually add value to society, while add value to the ecosystem, while also making sure that we have enough money to develop future products.
Interesting approach to have an exciting vision to back. So we have been sharing the same conviction as you have on your vision. But what make you choose Piper Serica and shake hands up and take things forward?
Okay, what made us choose Piper Serica? I think that's a very interesting question. See, the reason why we choose Piper Serica is twofold. First is, it's a large fund. It's an institutional fund. We understand how institution works. We understand how institutional thought process works. Again, I learned a lot while this transaction was going on from Abhay and Ajay. I used to literally call Abhay and ask him, what's the thought process behind this? I want to understand. that's a lot of learning that came on board for us in that sphere. Additionally, when we explored out, we also have to look for our future rounds as well. So we asked ourselves, okay, uh, is Piper Serica somebody who can back us up for a long term? And that's where a resounding yes came in. And as always, quick decision making is something which all founders love. That was also provided by Piper. So because of these reasons, I think uh, we our last round was oversubscribed by 2 times, but we made sure that Piper Serica has has a chunk that we can, that will help us out in a longer run. So that was our thought process.
Thanks for the good words. So, sure. So, I think it was good understanding the work. We have a lot more things to take a deeper dive, but we'll try to conclude things here because this might not be the last podcast we are having. This is the first one, so we'll try to take it forward. And all the best, Manan, for the vision you are having forward.
Thank you.
Looking forward to take things up.
Thank you.
Thank you.